Good morning, students. Welcome to second lecture on design and analysis of algorithm. Today we will, as we have in the first video, I have just described about what is a Tower of Hanoi, how it was played by a Brahma rituals as a puzzle, and basic things were explained. So let us go to the Tower of Hanoi algorithm. In the Tower of an algorithm, as the requirement is a number of disks, so n specifies here number of disks. X is the main tower, Y and Z are the auxiliary tower. Or you can say X is the source, Y is the destination, and Z is considered as an auxiliary tower or temporary tower based on which the movement of disk needs to be done. The first attempt is to move the top end disk from tower X to tower Y. So let us take, first thing is we should have the number of disks. So our first criteria or a condition to check is our n should be greater than equals to 1. If we have more than one disk, then we have to go to the algorithm, else directly we can move that. If there are no disks, then there is no meaning to move those disks from any tower. So first step is initially we have to transfer first n minus 1 disk from X to Z with the help of Y. The meaning of this is first tower indicates the source, second tower indicates the destination, and the third one includes the temporary one. So it's same in this case. Here X is a source, Z is the destination to move n minus 1 disk, and Y is an auxiliary tower. Once n minus 1 disks are moved from X to Z with the help of Y, then there is only remaining one disk, that is nth disk, which is present on tower X. So at the end we can move that nth disk from X to Y. With this perspective, what happens? Our one disk from X went to our destination Y, because main motto of or main destination tower is our Y and source is our X. Then after once that final disk is moved from X to Y, we can move our remaining n minus 1 disk from Z, which were present on Z at the previous step, should be moved, which is a destination disk Y, with the help of X. So this let me explain with the help of a figure. As per the algorithm, suppose I have three towers, tower X, tower Y, and tower Z. This is our source, this is our destination, and this is a temporary tower. Suppose I have n is equals to 3 disks, so I can say 1, 2, and 3. As per this algorithm, X is my source, Y is my destination, and Z is used as a auxiliary tower. At the first, check whether n is greater than equals to 1. Yeah, my n is 3, so 3 is greater than equals to 1. Condition is satisfied, so we can enter this loop. Here, n minus 1, move n minus 1 disk from X to Z. So here n minus 1 is 2. 3 minus 1 is 2. So first 2, I have to move it to Z with the help of Y. So how can I do? I can remove 1. I can place my 1 here. Then I can remove 2. I can place 2. I can remove 1. I can place 1 here. So in this way, I moved n minus disk from tower X to tower Z with the help of Y. As per the algorithm, I have to move n minus 1 disk from X to Z with the help of Y, which I have successfully done. So right now my towers are, I have only one disk at X. At Y, I don't have any disks. At tower Z, I have disk 2 and have disk 1. So by the algorithm, what I have to do, I have to move the nth tower, that is a topmost disk, from X to Y. So simply I have to remove this from X. I have to move this into Y. So now X doesn't has, the third step is X doesn't has any disks, Y is having the third disk, Z is having two disks, disk 2 and disk 1. My final step is to move this n minus 1 disk from Z to Y with the help of x. So now what can I do? I have to make use of x. So I will cancel, remove 1. I will place 1 in x. I'll remove 2. I'll place my 2 here. I'll remove 1 and my place my 1 here. In this way, successfully I have moved all the disks enders from tower x to tower y with the help of tower z. This is about Tower of Hanoi. Let us move ahead. If any query, you can give in the comment box. Next topic in design and analysis of algorithm is performance evaluation. Performance analysis with respect to all the concept, all areas is to be measured is mandatory, because without performance evaluation you cannot say that product is good or bad. So performance evaluation in case of algorithms can be divided into two major phases. One is called as performance analysis, which is done prior, before that product is developed or before that algorithm is given to the market. You can estimate the analysis of that algorithm, or after done posterior testing, once it is designed, then you can say performance measurement. You can, once the algorithm is designed, you can identify and say what is a performance measurement. That is called posterior testing. So today in our syllabus we have performance analysis. So performance analysis is divided into two types. One is space complexity, another one is time complexity. Let us understand the details of both in brief. Space complexity is by an algorithm is defined in many ways. Priorly, space is nothing but it is the amount of memory space used by that particular algorithm. Any algorithm space complexity is defined by the amount of space that algorithm is going to use during the runtime of that particular program. So it is defined by the memory usage by that program for its runtime. Now, since space complexity can be defined in two types, because we have different types of algorithm wherein sometimes the input is taken at the runtime and sometimes the input is taken at the as given in the program. When the input is given in the program, you can directly define the amount of space used in the memory based on the variables defined, because since the declaration of variable in the program is done at the start itself. If it is integer, it is given 2 bytes. If it is character, it is given 1 byte. If it is float, it is 4 bytes, and so on. So accordingly, we can directly specify the space complexity. But most of the algorithms won't accept the input at the in the program itself. There are certain cases where we need to provide the input at the runtime. Like suppose you have defined n inputs. So this n defines the size you are going to specify when you run the program. Suppose you are going to run the program at the first n is equals to 1, the amount of space required is different. When you are specifying n is equal to 5, the amount of race is different. So the space complexity of particular algorithm is defined in divided into two parts. One is a fixed part, second one is a variable part. Fixed part is said to be the one which is given in the program, that is which is independent of characteristics of input and output. It is an instruction space, or it is fixed size components, or the variables that you are decide, or the sum of the spaces for constants which you have given in your algorithm. The variable part is a size that is depend upon the problem instant, that as I specified, when n is 1 or n is 5. This is a problem instance and it depends upon the runtime variable. So in general, space complexity of any problem is defined as this constant p plus instance characteristics. So this can be a space complexity for any particular program. Since space complexity is not easy to be identified for any particular algorithm, because it depends on the size of the program. If the algorithm is very small, identifying space complexity is very easy. But if the problem is very big, so space complexity identification becomes a issue for directly to be calculated by manually, which cannot be indicated because we don't know at the backend operating system how memory management is done. So it can be obtained by using a specific technique in the algorithm to identify the space complexity. Next topic is a time complexity. This is the most important part, because when you are going to specify the time of that particular algorithm, It depends upon two phase, because while running a program, you're going to compile that for execution of that program, you're first going to compile that program and you're going to run that program. Now, compiling the program is not required every time. Once you have compiled, once you have come out with your technical, logical errors or the syntactical errors, it again depends on the instance characteristics. The compilation happens number of times, so it is not a concern. So mainly the time complexity is concerned on the runtime. So you can generally define for any particular program, your time complexity is a runtime of your program. So let us identify the time complexity for a simple program. Here is an algorithm, simple algorithm, which is going to calculate the sum of n numbers. A is an array which is going to have an array of numbers. N is the size of that particular array. Initially, yes, we have specified as 0 because we wanted to calculate the sum. So S is a variable which is going to indicate the sum value. Initially, we don't have any value, so we are going to give it as S is equal to 0.0. Now, I is going to iterate from n 1 to n, which is the size of array declared. And S is calculated by each value of iteration. When I is 1, the first value of I is calculated for sum. When I becomes 2, earlier sum plus next value is calculated. When I becomes 3, and so on. For the n values, the summation is done and the S is returned as a sum of the following problem. Now, how to calculate the time complexity of this particular algorithm? If you are going here, you can see same algorithm. What I have done, I have going to solve this problem by using a count method. It is a simple method to calculate time complexity. In this method, what we have to do is you have to just add a count increment statement after execution of each statement. Like suppose first statement is my S is equals to assignment. So I have added my count increment statement. Next is my loop. In this loop, I am going to add count increment statement, because every time you are going to execute your loop, the count is going to increment. Next is this statement, wherever addition of array elements is done, I am going to add a count increment statement, and this count increment statement is for the last condition. When for terminates for checking, when for checks whether the condition is satisfied, when the condition fails, it will not enter this loop, rather it will come out. So this count won't increment, but at the condition is checked. So for that purpose, we have another count increment statement. And the last one is count increment statement for the return is. So according to this, you can see this statement is executed only number of times. So my count value is 1 over here, because it is assignment is done only once for any program. This count statement is executed for all the value of n, so I can say n. This addition is done for all the value, so I can say count is getting incremented for n values. This is done at the last when my for loop for I less than n, when this condition fails but checking is done. So in that case, this count won't increment. So at that plot, this is incremented is done only once, and the return S is done only once. So total value for this is 2n plus 3. So the time complexity is 2n plus 3. This is about time complexity. In the next video, we will see another example of time complexity. For now, thank you.